Alright, so somebody explain to me what's the situation that we're supposed to be finding the average and stuff for. I don't even have the handout. Help me. Number of credit hours for like what kind of students? College students. I need more specific stuff. All college students?
College students.
Where are they?
16 random.
Just 16 random students. Did they tell us from where?
The intro stats class.
Intro stats class where? It doesn't say where. So this is just some random introductory stats class. Does that mean we could apply these results to all other statistics classes?
No.
We need to know more information. So always think about your W's. Don't forget about that, right? You want to think about your W's, what you know, how you can apply your results. Okay, so we're supposed to do what first? Put the data in and find the average, get your histogram, and find the standard deviation. So let's just use our calculator to create that histogram. I'm going to go in and clear out my functions, turn my plot on, turn the histogram on, put my data in the list one. Not going too fast. 15 times 4. 2 17s, a 19, 4 20s. And a 22. 16, yes, that looks right. So histogram time. Zoom what?
Zoom stats.
That's our god of Zoom.
I don't think you turned on here.
I didn't turn on my plot. No, I didn't. Zoom 9 again. A lot of the time, like if you have an issue, just hit Zoom 9 again. A lot of the time, you just kind of need to rescale it again. So there's a histogram. What do you guys want to do? Leave the bins like they are? Should we adjust them? What do you think? They look a little big to me, but not too big. I'm going to say let's adjust them a little smaller. What shape does it look like it has so far? Maybe trimodal. It kind of looks pretty symmetric to me. I'm not really sure if these are real typical values here. Let's make our bin smaller and see if we change our mind. So scale maybe a little smaller. 2. It's kind of looking bimodal to me. Maybe not. That one over there doesn't seem super common. It's a judgment call, right? I'm gonna make it a little smaller. Still looking pretty symmetric. I think what we had a second ago at 2 is a good size for the bins right there, personally. So if you said bimodal or symmetric, I'm with you. But even if it's bimodal, it's still symmetric looking, isn't it? So the rule of thumb that we should have in Chapter 5 in general, and for the rest of this class, which is one of the most important rules of thumb that we'll learn in this class, is that if you have symmetric data, and you're thinking about describing the distribution and then doing all the stuff that goes along with that we'll be learning, should you be thinking about the average and the standard deviation, or should you be thinking about what we did last week, where you look at the median and like the quartiles and the interquartile range? Symmetric, I think Party talked about how that's where we use the average. So symmetric distributions, things that look symmetric, it's generally a better idea to use the average. That's the mean. The sample statistic, you guys tell me, what was it? What was the symbol? X. Bar. We're going to later learn that X bar is the sample statistic, the godlike thing that you're trying to measure. The true mean we'll call the Greek letter mu. So I'm just going to stick that in here right away. Okay? So that's if you have a symmetric looking picture. If you have a skewed looking picture, like we had with that outlier last week with the burger places, if you have anything that's skewed, a skewed shape is going to suggest that you want the resistant measure of center, like Party of Sveti said, and that was the what? Median. The median. And what we haven't used too much yet, we used it a little bit in that example last week, was what spread goes with median? Interquartile range, or IQR, which is just, if you remember, Q3 minus Q1. Okay, today we're going to focus more on the average. We'll go back and do some more median stuff and IQR stuff tomorrow. But this chapter has both of those. It's going to ask you to do things with both, and you've got to be alive enough to decide which one should I be using for different scenarios. Okay, So I'm thinking we're probably going to want to stick with the average and the mean, just like this problem asks us to do, right? So fast way, how do you come up with the average? Didn't we do that last time?
Yeah.
Can't you go vars, calculate one variable statistics on whatever list you have? And it gives you all this stuff. See, now we're starting to look at these, and we should be seeing stuff that was symbolic today in that little video. These sum symbols have to do with stuff you might need to compute things like the standard deviation and other stuff. There's X bar, so there you go, it's right there. Or you can write it down. There's the average, 16.3125 units. Remember, units, unitless numbers in this class mean nothing almost always. What are the units on this one? Back to your context, credit hours, right? And then which one of these things do you think is the standard deviation? Because it gives it to you right away. It's important to know where it comes from, though. If you know where it comes from, you don't know statistics. Which one of these is the standard deviation? This one. S sub x. So standard deviation in your notes. I should have written that up here, sorry. Measure of spread we're going to be looking at for average stuff or symmetric stuff is the standard deviation. The sample standard deviation, the only thing you'll pretty much ever have access to in real life, unless you're God, is S sub x. That's the thing you get from the sample. That's what we're going to compute. The calculator obviously did some kind of magic and got it, right? This thing, the calculator is always lying about, so I never want you to use this number. This sigma thing is the real standard deviation, and to put a subscript x on it is just blasphemy, so whoever created this calculator is a fool right there. It should not have a sub x on it because it's not coming from a sample. This is the real standard deviation if you were God and knew every piece of data that was out there. Does that make sense? If you could actually add them all up. Of course, human beings don't have that unless your data set is like the 5 people with this really rare set of cancer. Then you can do that. So that's really rare in the real world. We'll talk more about that issue. But today we're going to focus on standard deviations. How did they come up with this number? What was the formula? I think we had the formula for creating S sub x. It was the sum of the deviations, so subtracting away the deviations of each piece of data from the center that we're using, the average. And we square it, why again? Because some deviations are this way from x bar and some are this way. If you square it, that helps you avoid thinking about positives and negatives. It's just all going to be positive. And then you divide it by n minus 1 to scale it back down. And that is this, what word did they use in the video? I think she just said it once. That is the sample variance, which we'll be seeing variance quite a bit. To get the standard deviation, you have to square root it. So this is the formula you will see that we'll be using. So let's do that one step at a time using our calculator's list. So here's where you want to follow along carefully with the calculator. Now, of course, on the AP exam, can you always just use this one? Sure. But there might be questions on the AP exam where there are sometimes where they're like, create a new measure of spread. And instead of doing that formula, tweak it a little bit, like put a 3 right here. And how does that affect your results? That's one reason you might know to be able to do this. That's for a really hard AP question, like the hardest thing they could ask you with math. But it's important to be able to know where this came from. So let's do it. So it says first, we've got to take each x sub I and subtract the mean, right? So let's go into our lists and do that. So I'm going back to my list. There's my data. Let's not get rid of it. In list 2, I want to take and put each x sub I minus the average. So what was the average? I should have written that down. Shoot,
16.31.
Okay. So over here then I want to take each value. Each value is stored in list 1, is it not? You guys see I'm up in the title screen, so it's going to do this all at once. I'm going to take each value and subtract the average. 16.3125. Enter. Calculate, calculate, calculate. So it populated that for us. There's the deviations from the mean. Now we need to protect against left or right. So in list 3, let's take each one of those values and square it. So each one of those values is now in list 2. So I'm going to square list 2, and it's going to take each one and square it. I'm taping this, so you can go back and look at it again if you want. And let's see, so then we need to take that whole thing and add it up, right? That's not going to be in a list. Now we just need to add that whole list up. So I'm going to go out to the home screen. Which list are we in?
3.
List 3. So all of our stuff is in list 3. We've got the squared deviations from each one. This symbol, if you don't already know that, you guys should. Well, maybe a couple of you in Algebra 2 beginning don't know it yet. This means sum or add up. So I'm going to add all of those up. So the way you do that in your calculator is you go statistic. Oh wait, I think I'm wrong. Quit. You hit second statistic. And then just start looking around for a sum. I don't see it. You guys see it? Nah. You guys see it?
Yep.
Yep. Sum of what?
List 3.
List 3. So far we have the sum of the deviations squared. What do we need to do now? Take that number and divide by how much? We had how many data values? 16. So we're going to divide by
17 or 15.
15. So we're taking 16 minus 1. And now we're going to do what with that last step?
Take the square root.
Take the square root. 3.700, is that what the calculator said a second ago? Let's go back and look. 3.700, if you run it the cheap way. There it is. So that's how it's computing that number. And notice, these are things that you could use to construct other statistics besides the standard deviation. So this gives you the sum of the list. That's the sum of the list. This gives you the sum of all the values in the list squared. So don't let all these things scare you. I've pretty much shown you what they all are now. Yeah, we've got it all. Average, sum of all the things in your list, sum of all the things in your list being squared, standard deviation of the sample, and terrible, awful, fake thing. Okay?
Yeah.
Does that thing actually have a meaning? Yeah, but let's just pretend it doesn't. Okay. Good to go. What else does this problem ask for us to do, guys? Find the median interquartile range. We already decided based on the picture. We weren't real sure on this one, but it looked symmetric, so we probably want to use these. If we find the median and interquartile range, Party showed you guys how to do that, right? Line them all up. Let's just use our stuff right here. Let's just pull out the median and interquartile range. You guys remember they just scroll down. Oh, wait. Let's do it again. See how easy it is to do this? So the median is 16. It's very close to the mean this time, isn't it? If you remember the video and just use common sense, that's because it has a symmetric shape. If something is perfectly symmetric, the median and the mean are the same. So you're going to have some tricky problems in this chapter that are going to ask you, okay, what if you double all the values? What's that do to the mean? I think she went over that in her example, didn't she? If you double all the values, what's that do to the average? If you cut all the values by a quarter, how much does that affect the average? How much does it affect the median? And you're going to have to think about those problems in different ways. Those are great conceptual kinds of things. They're not real world problems, they're more mathy conceptual things. So you'll see some problems like that in your set. So what is the IQR? You guys should be able to pull out the IQR there too. So the standard deviation, I should write it down, we got was, I'll stick with, let's go back and do red on this problem. So for our problem, example 1, we got that X bar was 16.3125, and oh my god, I almost wrote it down. It's dangerous. Give something like that. And using the competing statistics, we got that the median was what, 16? And the IQR is what? 5.5? Notice, while the measures of center on this problem are real similar, the spreads are pretty different, aren't they? Isn't the blue almost double or 1.5 times the red? So those are pretty different. So, is it more appropriate to use the mean and standard deviation? We already talked about that part, yeah? We're thinking average, mean, and standard deviation are better because this one's more symmetric. A little bit of a tough call, but In that picture, did you guys see anything that would suggest that an average would get yanked up this way?